going to look at common factoring. So before we look at common factoring, let's talk about what a factor is. A factor is a number or a variable that divides evenly into a given term. So for example, if we look at just numbers, if I'm looking for factors of 6, I want numbers that divide evenly into 6. So if you remember, 1 times 6 is 6, which means that 1 and 6 are factors, as well as 2 and 3, because 2 times 3 will also give me 6. Okay? So the greatest common factor then is going to be the largest number or variable that divides evenly into each term in a set of terms. So if I give you more than one term, then the greatest common factor is going to be the largest number or variable that divides into all of those terms. Okay? So for example, if I give you these two terms, I'm going to give you 30x squared and y to the exponent 5 and 18x cubed times y. And I want to look for what is the greatest common factor. In these two terms, you'll notice that there's two parts. There's the number, which is called the coefficient, as well as the variable part. So let's look at each piece separately. Okay? If I'm looking at just the coefficients, so the 30 and the 18, what we want to do is we want to look at what are factors of each number individually. So if I look at 30 first, we want numbers that are going to divide evenly into 30. So it's easier if we group them based on what two numbers multiply together to give me 30. Right? So the easiest one is always going to be 1 times the number itself. So 1 times 30, that gives me 30. Okay? So other factors of 30 are also 2 times 15, 3 times 10, and 5 times 6. So those are all my factors of 30. The next thing I want to look at is now factors of 18. Looking at factors of 18, we'll start off again. We'll pair them up. 1 times 18, that's going to give me 18. I have 2 times 9, as well as 3 times 6. So now I have all the factors of 30 as well as all the factors of 18. And we want to look for the one that's the largest that's common to both numbers. Okay? So if you look at the numbers, we can see that 1 is a common factor for both. 2 is also a common factor, but I want the largest number. So the largest number that's in common to both 30 and 18, that's going to be 6. Okay? So looking at the coefficients, that's the greatest common factor of those parts. Now let's look at the variables. Okay? So for the first term, I have the variable part x squared and y to the exponent 5. In the second term, I have x cubed and y. In order for me to look at the greatest common factor of those variables, what I want to do is I want to look at each piece as it is in expanded form. So let's go back to where things come from. X squared and y to the exponent 5, I can write that as x times x and then 5 y's multiplied by themselves. I can do the same thing with the second term. X cubed times y is really 3 x's being multiplied together and a single y. Right? So if I'm looking for the greatest common factor, so these are all the variables that multiply together to give me the variable part. Those are all the factors. I want to look for the part that's the greatest. So we're going to look at each piece separately. If I look at just the x's, you'll notice in the first term I have 2 x's, whereas in the second term I have 3. So the most that I have in common to both of those terms then is 2 x's, right? So we're going to write that that's the same as x squared. So x times x is x squared. That's going to be the x part of the variable portion. And it is the same thing with y. You'll notice that the first one has 5 and the second one has only a single y value, which means that the most I have in common for both of those terms is just 1 y. Okay? And so now I have all 3 pieces of my greatest common factor. I have the numerical part, which is the coefficient. I have the x parts, which we said because there's 2 of them is an x squared. And I have the y part, which is a single y value. So putting that together, I can say that for the 2 terms, 30x squared y to the exponent 5 and 18x cubed y, the greatest common factor is going to be 6x squared y. Okay? So looking at that carefully, we can see that if I'm looking at greatest common factors of variables, what I want to look for is the smallest exponent. That's a good trick for us to remember how to find greatest common factors when I have variables. If I look at the x portion, the most I'm going to have in common to both terms is always going to be the smallest exponent. So in the first term, my smallest exponent, or my exponent on x, was 2, which means that that's the most x's I'm going to have in that portion. So comparing the two, exponents, there's a 2 as well as a 3. The smaller number is 2, which is why x squared is my smallest exponent and therefore my greatest common factor. Looking at the y's, I can see the same thing. There's a single 1 as an exponent on the second term, and that's smaller than 5, so my greatest common factor can only have a single y value. Okay, so let's look at common factoring with an example. Here I have a polynomial that has two terms. So last time we talked about how that's called a binomial. And if I look at the two terms, I'm going to do the same thing we just did. We're going to look for a greatest common factor. We have to look at the numerical part as well as the variable part. Okay, so 12x cubed minus 6x squared has a common factor of 6x squared. So 12 and 6, the number that's the greatest common factor is 6. X cubed and x squared, remember we said we're going to look at the smallest exponent, which is 2, so that's going to give me 6x squared. In order to factor, we're going to look at what's called opposite operations. So factoring is the opposite of what we learned previously, which was expanding, and expanding involved multiplication. Factoring then means I want to bring it back to two things being multiplied together. So to get back to multiplication, I'm going to do the opposite, which is called division. Here in this polynomial, we said this is a binomial with two terms. So what I want to do is I want to take that greatest common factor and I want to divide both of my terms by the greatest common factor. So for this example, I'm going to write that in. I'm going to say that I'm going to take 12x cubed and I'm going to divide it by 6x squared. And I'm also going to take the second term, 6x squared, and I'm going to divide that as well by 6x squared. So the division of the opposite operation is then going to give me what's left over as a multiplication. So if I divide the first term, 12x cubed divided by 6x squared, that's going to leave me with a 2x, and I'm going to put that into a separate bracket. Okay? The second term, negative 6x squared divided by 6x squared, that's just going to be the exact same number, so I'm going to reduce that to a minus 1, and I'm going to put that in the bracket. Okay? You'll notice that now what we have is the greatest common factors on the outside, and what's inside the bracket is what was left after the division. So because I had two terms to start off with, I should also have two terms that are left after I've done a division, because I've divided two terms, so I should have two terms left over. You'll notice that these are not like terms, so I can't combine them. I should still have two terms inside that bracket. And if I were to take the greatest common factor and multiply it back into the bracket using our distributive property, you should get back to the original question that we started off with. So 6x squared times 2x, that gives us back that 12x cubed, and 6x squared times negative 1 is going to give me negative 6x squared. I'm not going to do that because that means that I haven't done anything, I've just gone back to the original question, but that's a good way for us to check to make sure we have the right answer. Okay? Let's look at another example. So like I said, 3xy plus 2y. If I look at this, the only thing that's common to both of these terms is just the single y. So this time I'm going to take out the y, and in brackets I'm going to put what's left over after I divide. 3xy divided by y and 2y divided by y. I'm not going to show the division this time, but I'll be left with a 3x plus 2. Okay? We're going to use this example now to look at the next one. If I have 3x times x minus 1 plus 2 times y minus 1. This is now taking a similar example, so if I look at B, we're going to compare this to C. If you look carefully at it, you'll notice that instead of having y, all we've done in this part C is replace the y with a binomial, which is y minus 1. Okay? In part C, I still have two terms. We said what separates terms is adding and subtracting. And here, between the 3x and the y minus 1, that's multiplication. There's no addition sign between the bracket and the term, so that's a multiplication which keeps it as one single term. So part C still has me looking at two terms, even though those two terms have a binomial in it. Okay? So like I said, we're going to compare the two. Where there was a y in part B, we've replaced it with the binomial y minus 1. So you'll notice that in the two terms, that y minus 1, that is my greatest common factor, or the common factor to two terms. It's the binomial factor instead. So I'm going to do the same thing that we did with the previous example, and I'm going to take that y minus 1 that's common to both of those terms, and I'm going to take it outside. Okay? What's going to be left in the bracket then is just going to be what's left after division. So if I were to take that first term and divide y minus 1 divided by y minus 1, because it's the same, what's left over is just going to be the 3x and the positive 2. So 3x from the first term, positive 2 from the second term. So earlier we said that when I started off with 2 terms in the question, I should still have 2 terms left over after the division. So because I'm dividing out a y minus 1, in the second bracket now, I should be left with 2 terms, my 3x plus 2. So this is now 2 binomials being multiplied together. If you were to expand it using the distributive property that we previously talked about, you should get back to the original question.